Hi everybody. Now let's have a look at the main difference between the Joule Thief and the Bedini circuit. Here at the top you can see the Joule Thief, and my premise is that the only difference is the connection of the trigger coil, because as you see, the main coil, the run coil, is hooked up to the positive of the battery. This is an AA battery, and it's down to negative, through a transistor. This is the collector, this is the emitter, and this is just a small signal transistor. Okay, any kind of NPN transistor does the job. And here's an LED, hooked up across the transistor. On the positive is the collector, the negative on the emitter side. Okay, so it's a 1.5 volt maximum, which is way too low for the diode to turn on. But with this simple configuration, you can make this bifilar coil oscillate. Okay, so here is the run coil, but the trigger coil is also connected to the positive. Okay, and that's the main difference from the Bedini, because here is the trigger coil, and it's via 20 kilo ohm or maybe a 10 kilo ohm resistor. It's hooked up to the base, and this is self-starting. Okay, while the Bedini at the bottom, you can also see the run coil connected to the positive, and the same way, the transistor, the diode, the emitter down to ground, while the trigger coil is hooked up to the negative of the battery, and the same manner it is hooked up to the same resistor, can be of different value, and across this resistor you can experiment by putting a very small ceramic capacitors here and here. Okay, and with a little tweaking and experimenting, you can increase the light emission rate, the volume, and reduce the power consumption. Okay, but this is just the simplest form. I didn't use any capacitor. Okay, so here is the trigger coil, and it actually triggers the base, and so it turns on and off the circuit. Okay, now let's see everything in real life. Please bear with me for a second. I need to reposition my camera. Yeah, here it is. Okay, good. As you see, the idle voltage of the battery is 1367 millivolts. And I usually use this method, okay, because it's just connected across the battery in parallel, and then you can determine by the voltage difference between the idle voltage and the load voltage how much power is being taken from the battery. Because if you connect it in series with the milliamp or microammeter function of the multimeter, it usually interferes with these small signal circuits. All right, so the idle voltage is 1367, and everything is hooked up, hopefully, but it's not self-starting. Okay, let's try to kick it off. Here we go. You can see it's on, but the voltage dropped to 1364. Okay, only 2 or 3, I think 3 millivolts. It's very small. I think it can operate for weeks on end. Let's see how bright is it. Well, not very bright, but I think it's good for emergency implementations. All right, now back. Okay, so if you want to stop it, you just disconnect the battery or anywhere in the main circuit momentarily. Okay, and then it's off. All right, so if you want to start it again, yeah, this is it. It works. Okay, it's on. 1364 millivolts, off. 1366, maybe 67. Okay, so 2 or 3 millivolts. It's really very, very little. All right, now the Joule Thief is next. I disconnect the trigger. This red lead is connected to the trigger side, and it's self-starting, as you see. Okay, probably it's lighter, okay, probably it's lighter than the previous configuration, but the voltage drop is also more significant because it's 1357, okay, that was 67, 57, now it's 10 millivolts drop, okay, so it definitely, even 11, it definitely uses more power, so the current consumption is higher, but it's also very economical, okay. So this is my main premise, that this is the only difference, or the real difference between these two coils, okay. Let's go back to the Bedini configuration. Okay, it's not self-starting, yeah, but if you momentarily just short the transistor out and create yeah, at the bottom, okay. So if you short out, this is the battery, okay. I just put this these tweezers across here, okay, and I shorted the transistor, and it started the magnetic field build up in the core, and then it started the oscillation at the base, okay. So it on and off, and then it's on, all right. So it is also useful because as far as my experience goes, the least reliable part of the circuit is a switch. If you build a for example, flashlight or something, or emergency light, the switch is usually the weakest link, okay, because it has moving parts, it has connecting, disconnecting parts, you know, physical problem. But if it's only a push button, okay, or a momentary switch, it only needs to establish connection for 1 millisecond, and then it's on, and it's stable because it's kind of a it's like a transistor latch, all right. Actually, it's a transistor latch with only one transistor, but it works only with the Bedini configuration, because the transistor latch needs 2 transistors, as far as I know, okay. So it's not very strong, but let me show you some Joule Thief of mine. Okay, so this is another one, as you see. Yeah, it's pretty powerful. Only one, yeah, okay, so it has quite a few LEDs. 4, yeah, it's 4, okay, not bad. Okay, but this is a very good flashlight. It runs only on one battery, one AA battery, if I'm not mistaken. Yeah, here it is. Yeah, it's one AA battery. All right. Again, the switch is the weakest link. And I have other builds. Maybe you can check out my channel, because there are other videos. There is one with a stepper motor, and it also establishes the same contention about the main difference between these two circuits. But I used a stepper motor setup instead of a solid state setup. All right. Thank you for watching and bearing with me for my blunders. Peace, everybody.